Okay, we're going to go ahead and take a look at this question here, which is a probability question using combinations. In this particular question, we want to know the probability that exactly two are chosen from the given subgroup, being blue fireworks. So in this scenario, we have a technician launching fireworks near the end of a show. Of the remaining 13 fireworks, so 7 are blue and 6 are red. So we know there are 13 total, and we're breaking those 13 into two subcategories, the 7 blue and the 6 red. She is then going to launch 6 of those fireworks in random order, and we want to know the probability that exactly 2 of those 6 that she's launching are going to be blue. So we'll take a look at how to do this here on the next screen. Okay, so here's what we know so far. We know that we have 13 fireworks, 7 of which are blue and 6 of which are red from our remaining fireworks. So I've kind of illustrated that here on the whiteboard. We must choose 2 blue, because they want to know the probability of choosing exactly 2 blue, and that means we have to choose 4 red, because they told us we were choosing 6 altogether. If we have to choose exactly 2 that are blue, we still have to choose 4 more from the other subgroup to have exactly 6. So we have to choose 2 blue fireworks from the blue fireworks we have, and then we're forced to choose the other 4 fireworks from the red fireworks, since exactly 2 of them have to be blue. So we're going to set up some combination problems to figure out how many ways we can do that. So let's deal with the blue first. We have 7, and we want to choose 2 of them. So we'll do a 7C2 like this to figure out how many different ways we can choose 2 blue fireworks from the 7 fireworks that we have. We will also complete this by figuring out how many different ways we can choose 4 fireworks from the 6 red fireworks that we have. So we have a 6 total, and we're going to choose 4 from that. And this product will tell me how many different ways I can choose 2 blue fireworks and 4 red fireworks from what I have. Now, to turn that into a probability question, then, we need to go ahead and divide by the total number of outcomes. We are going to choose, in this problem, 6 fireworks to launch from the 13 fireworks that we had altogether. So we have 13 altogether, and we will choose 6. So this bottom of this fraction, this denominator, should represent the total scenario. You have 13 fireworks altogether, and you're going to be launching 6 of them. The top of the fraction then actually breaks it down into the 2 subcategories. You have 7 blue ones, and you need to choose exactly 2 from the blue, and you have 6 red, and you have to choose exactly 4 from the red. Again, they told you were launching 6, so if you had to have exactly 2 from the blue, that means that the other 4 had to come from the red fireworks. That's a spot where people sometimes get confused. At this point in time, I'm just going to go ahead and go to my calculator, and I'm going to compute each of these things. I could work them out by hand, but I don't really feel like it. So 7 choose 2 would be equal to 21. 6 choose 4 would be 15. And then on the bottom, how many different ways I can choose 6 from 13 would be 1,716. Go ahead and doing my multiplication on the top. 21 times 15 is 315 out of 1,716. Go ahead and divide that, and then multiply by 100 to move your decimal over to convert it to the percentage, and we will get that this is 18 point, I think it asks us to round to 3 decimal places on this, so this would be 18.357%, like that. So again, I divided the numerator divided by the denominator there. That gave me 0.18357, etc. And then I multiplied by 100 to convert it to the percentage, and I rounded that answer to 3 decimal places as it had asked in the problem. Please let me know if you have questions about any part of that problem. I can try to answer and clarify, but that's where we stand on this example.